Clear? How many you got? There is an Atma zone. Ma'am, you are talking, don't take. Okay. But how much you got Darshan? 22. And the football. Here. Your results are come? No. So permanently front bench, no? Yes. Viraj.
Every day he comes and asks me for a friend.
Yeah. Form. Next time come and meet. Mommy said you get study. But you don't get the what to do? How can you make them happy? Not good. In school parks, there is no. 80 marks paper, you have to get good mark. Yeah. Sit down, all of you. Look. Chapter we started with circle now. Yes. Theorem we are done now.
Yes, sir.
Which is standard? What? Yeah. All of you close the volume. Stand up. Prove the theorem. 1 minute time. Okay. Figure okay, rough figure. Who is talking there? Shreya? Nobody talking. Who is talking the other side? Yes. All of you close the volume. Okay. Tell me what is the theorem? No need to write anything. Theorem.
Tangent is perpendicular to the radius when it is in contact with.
Tangent at any point is perpendicular to the radius through the point of contact. Okay. Given. Given. You don't need to write. You tell me.
Given OP and OC are radius.
What is this OC?
Radius.
That is not given. Go back. Go to the side. Next. Shreya standard. Come in. Yes. Yes. Given.
The given is that.
Betty, you are not done. Okay. Now. Given
is that OP is the radius and the.
All of you be quiet.
And the line PQ is the whole line in PQ is the tangent.
Circle with center O, OP is the radius and PQ is the tangent at which point?
At point.
At point P. Okay, what do we need to prove?
That OP is perpendicular to.
OP is perpendicular to PQ. Okay. Yeah, name it as another name. AB, make it as tangent name. Put arrow on both sides. Okay, AB. So that OQ don't take, okay? Because Q is something different. That is not in the given condition. AB is the tangent at P and OP is the radius. To prove is OP perpendicular to PQ. Okay. Then start the proof.
So, sir, OP is the radius, and let Q be another point on the radius tangent AB. So OQ will be on the OC is the point. OC will be the radius because it's
From where you got the C and all? I did not explain any OC and all. Did I explain any OC or something? You wanted the C and all? You want to make any changes in this figure? No. Okay. What is this OC and all?
So the OC is the radius.
What is proof statement? First statement. What is the first statement?
So OP is the radius. Q is the point on tangent AB.
Use the point on that in
Other than Q.
So tell who opened the volume?
Yeah.
Take a point Q on tangent AB other than the point P. That is your first statement. That also you cannot tell properly. Okay, continue. Then.
Then taking OC.
Very good. Very good. You made a new proof of it? No. Textbook proof only you learn now. Okay. Next. Daisha. Go. See, two people could not do it. Yeah.
Draw a line from the start or after working steps.
Proof is start. Proof is a.
It is given that OP is the radius, and then
Everyone is doing OP radius, OP.
okay. After that, we have to draw a line OQ anywhere other than point OP.
Anywhere other than OP.
Other than point P.
Q is any point other than point P.
Yeah.
On where? On the tangent AB. Okay. Then.
And OQ is greater than the radius because
And proof.
no.
Wow.
Then
what is it?
It
Okay.
is greater than the radius because it is outside of the circle. It is exterior to the circle. If it's inside the circle, it is a second, and if it is
Second.
yeah. Indeed, I read the proof. If it's inside the see, it has
Don't move from there. Okay.
it has to be exterior to
It
the
has to be
circle.
exterior.
No, it is larger than the radius, but
Richa,
it is outside of the circle.
Then what she's telling is correct, no? You agree? Okay, come. Continue. Where is that? Yeah. Move that side. Both of you move to that side. Go back here, please. Okay. Use. Okay.
So OQ is greater than OB because
Okay.
OQ is greater than OP because the point Q lies exterior to the circle.
Why Q like exterior to the circle?
Because
Yeah, who is the
the tangent. If Q
the explanation that matlab will not be there.
if Q
Next, if Q is going up.
if it lies in like in
There.
something that line would not be a tangent anymore.
Over.
So since OP is the shortest distance to tangent.
Done. Hence proof. 3 marks. Alright. One proof. So, proof. I did not hear a proper proof from anyone.
So it is given that OP is the radius and AB is the tangent, which is intersecting. The point of contact is point P, and we have
Given
to,
to prove, you don't need to tell the remaining part.
okay. So we can see that OP is the radius, and we should take another point Q on exterior, which should be exterior to the circle, and this point OQ will be greater than point OP. And a line from a point to another line, the shortest distance of a line from a point to a line is always perpendicular.
So retelling is making.
No.
Then proof here telling.
Yes.
I did not. So who agreed with him? You agreed.
Sir, in school we are taught the same.
School everywhere taught the same thing only. Very good. Come. Okay. Yeah. Go. Complete. But why time 5 minutes is wasted only now?
Sir, in this figure, OP is the radius.
Everyone
So-
knows an OP radius, OP radius. Beyond that, it is not easy. OP radius. Two things I heard from everyone. OP greater than OP.
So
Right over.
in this figure, we can see that OQ is greater than OP because so we cannot say that it is
We
the
cannot
shortest distance from a point to a line. But in this OP,
We can see C and all is not the answer, okay? Proof is the answer. Go ahead. Me also. Now who is the other one incoming? Visha is going to come. Just stand there and now stand and tell.
The point Q lies in the zero of the circle. So when it lies in the line, AB would be a second, but it's
Not second, secant.
but it's a tangent. So the point Q lies on the exterior of the circle. So if it lies exterior of the circle, then OP is greater than OP. Therefore, OP is the perpendicular at the shortest distance.
Perpendicular, shortest distance. Sit down. Listen. Do you want to tell?
नहीं सर ये
yes,
मैंने किया था चार मैं करूँगी
Hello. I'll ask him to prove. Listen. Given to prove, that is over. After that, the proof. Statement 1. Take a point Q exterior to the, take a point Q on the tangent AB other than the point P. That is the first statement. These are compulsory statements. Next statement, join OQ. That is the second statement. Now when I finish everything, sir, we also said. But I did not hear. When I ask you to write, then I will come to know. Third, point Q lie exterior to the circle. Reason. If Q lie inside the circle, PQ will not be a tangent. Or Q lie on the circle, then also PQ will not be a tangent. Both the case it will be a secant. Therefore, point Q lie exterior to the circle. Next step you will write OQ is greater than radius. Reason. If a point lie exterior to the circle, its distance from the center is more than radius. But OP is radius. Therefore, OQ is greater than OP. This much steps you have to write. Otherwise, in a 2 lines over, then you will not get any mark. So, OQ is greater than OP. That is there. Till there, you have to write one by one step. Whatever I said. Then, next is, similarly, if we take any point on the tangent AB other than point P, that point will always lie exterior to the circle. Therefore, its distance from the center will be more than the radius. Therefore, OP is the shortest distance between line AB and the point O. We know that the shortest distance is the perpendicular distance. Therefore, OP is perpendicular to AB. Some of you are perpendicular is two degrees. Then we said exterior, all this. Write properly, then only you will get the mark. Understood? It's not that every step one by one properly you have to write. Everyone has to write the proof. How many of you read the proof from the volume or textbook? 1, 2, 3. Yeah. Put the hand down. Now listen. Listen, all of you. Next is, if you consider any point on the circle, they can draw a tangent. If you take a point B, tangent. At the point C, there is a tangent. Any point on the circle, you can draw a tangent. Therefore, a circle for a, what happened to you? Sleeping. Then, therefore, for a circle, how many tangents can be drawn? Infinite tangents can be drawn. Remember these are statements. Circle, for a circle, how many tangents you can draw? Infinite. For at a point, how many tangents can be drawn? One tangent. Through this point, how many lines can be drawn? Infinite line. If you consider this point P, how many lines can be drawn? Infinite line. Hello? Listen. Then, out of which one will be the tangent. I repeat, if you consider the point B, through the point B, how many lines can be drawn? Infinite. Out of which one will be the tangent. All others are secant. Are you followed? Through this point, lot of lines, infinite lines we can draw. One will be the tangent. All other lines, if whichever the line draw, it will intersect the circle in 2 points. They are secants. Are you followed? Is it clear? Next, normal. You know what is normal? You know what is abnormal. Normal. You know what is normal? Which is the line which is perpendicular to the tangent and passing through the point of contact. In the OP is the normal. Normal will pass through the center of the circle. Are you followed? What is normal? Line which is perpendicular to tangent and through the point of contact which passes through the center. This is the normal concept. Clear? Followed? What are the complete properties are followed? This page is the first theorem and its properties. Hope you have followed. Open your volume. How many of you did the practice homework and all? Why? Where is the volume? Lost. Why? Then who is that? First one. Yeah. Practice, forget now. Tell. Page number. Open.
Exercise.
Page number, first page you take. Page number 19. Taken page number 19. Okay. Yeah. Yani, read the introduction. Introduction, read loudly. Louder.
A circle is a collection of all the points in a plane which are at the constant distance radius comma fixed point center. Let us consider a circle and a line PQ. There can be three possibilities as given below. In the first case, the line PQ and the circle has no common point. Here PQ is called a non-intersecting line.
PQ is the non-intersecting line. All the points are exterior. Okay. So what happened there?
In the second case, there are two common points A and B that the line PQ and the circle have. In this case, we call this PQ's secant of the circle.
Okay.
In the third case, there is only one point A which is common to the line PQ and the circle. In this case, the line is called tangent.
Tangent. One point is common between the circle and the line. That is called which one? Tangent to the circle. Okay. Continue, Shati. Tangent.
Tangent to a circle. A tangent to a circle is a line that intersects a circle at only one point. There is only one tangent at the point of the circle, and the other lines at that point are seconds to the circle.
Second. What is second?
Secant. Secants to the circle. The tangent to a circle is a special case of secant when two endpoints of its corresponding chord coincide.
Are you followed? Tangent is a special case of the secant. Secant intersect the circle in how many points? 2 points. If both of them coincide, then it will come to a tangent. Yes or no? See here. Suppose it is coming as this way. This is what? Secant. If this one it is coinciding, so it is rotates and reach over here means, but this line will meet the circle at only one point, then it will come as a tangent. So special case. That's all. Okay. Over.
The common point of a tangent to a circle, and the circle is called the point of contact, and the tangent is said to touch the circle at the common point.
Hope all of you followed this all we discussed. Okay. Atish.
So,
Theorem.
can you discuss the special case?
Look here now. Suppose this is a line which meets the circle in how many points? 2 points. Imagine this line meets the circle in 1 point. That means these points will coincide. Then that time it will come as a tangent. Understood or not? Okay, that's all. Yes. Adish, continue.
theorem 10.1 prove. Prove the tangent at any point of a circle is perpendicular to the radius to the point of contact. Given a circle with center O and tangent xy to the circle at point P. To prove OP is perpendicular to xy. Proof. Take a point Q on xy other than P and join OQ. Point Q must lie outside the circle. Bracket open. If Q lies inside the circle, xy will become a secant and not a tangent to the circle. Since Q is an exterior point, the distance from the center is greater than the radius. Thus, so OQ is greater than OP.
Reason is OP is the radius.
Since this happens for every point on the line xy except the point P, OP is the shortest of all the distances of the point to the points of xy. Therefore, OP is perpendicular to xy.
That is a proof. Okay. So remember the proof. You cannot reduce this one. You cannot delete any line from here. So you have to be very careful in case proof comes in the exam. Sometimes proof come in the exam. Arnav, continue reading.
Note, by theorem above, we can also conclude that at any point on a circle there can be one and only one tangent. The line containing the radius to the point of contact is also sometimes called the normal to the circle at the point.
Line containing the radius which is passing through the point of contact. Revolver, it is called the normal. Okay. That's all, no? Or sometimes called the normal. All right. This much is clear. Yes. Risha, exercise. Read.
Question 1. How many tangents on circle?
How many tangents?
Infinite.
Infinite. You have to read that statement properly. How many tangents a circle have means infinite. How many tangents a circle at a point means? One. So you have to read the statements properly. Continue.
Given the tangent to a circle intersects
How many points? 1 point. Riti,
A line intersecting a circle in 2 points is called a
secant.
A circle can have dash parallel tangents at the most.
Yeah. Listen. Parallel. Parallel. Are they parallel? More I can draw? Yes. More?
Yes.
So, answer?
Infinite.
Infinite or 2? Listen, don't write anything. Here, listen. Read the statements properly. A circle can have at the most how many parallel tangents? If I take these two, parallel. But these two are not parallel. If how many pair of parallel tangents means infinite pair. How many parallel tangents means at the most 2. These and these are 2. Okay, maximum 2. Answer in this question it is 2 parallel tangents. How many pair of parallel tangents means infinite pair. That's why you have to be careful. Okay, continue. Who is the reading? Okay, Shreya.
The common point of a tangent to a circle and a circle is called point of contact.
Are you followed? I don't need to explain anything. Okay, next. Tejas.
A tangent PQ at point P of a circle of radius 5 cm meets a line to the center O at the point Q so that OQ is equal to 12 cm. Then PQ is.
It's an MCQ. All of you do this one by drawing a rough figure. Whenever circle based question, always remember to draw a rough figure and check. It's not necessary, very compass and don't forget now. Draw a rough figure and see. Don't waste much time to draw this one. This can come for 2 mark question. At time maybe, no, 3 mark, no, 2 mark for MCQ. Figure draw and mark what is it. That is the thing I wanted to see. Not here in your notebook. This is the place. Then the teacher will check the answer over here. Next time I have tell the school teacher not check the rough work also. Rough figure I said. I wanted to see the figure I said. It is not the answer I wanted. Where is the figure? Now write the, when she got the figure, you have to. Krishna. Open the book and draw. Oh madam, why we say you cannot make over here? Array is in AC. Rough figure is not in the back side. Yeah. They just read the first statement.
A tangent PQ at point P of a circle
Tangent PQ at point P
of a circle of radius 5 cm meets a line through the center O at a point Q so that OQ is equal to 12 cm. Length PQ is.
So this figure comes. This Q can be either this side or this side. Now, over here, since it is an MCQ, you can directly apply Pythagoras theorem, and it is coming as 5 square plus PQ square is equal to 12 square. Therefore, PQ square is equal to 144 minus 15, that is equal to 119. Sorry, 25, that is equal to 119. So, root of 119 is the answer comes. Look here. This same question can come for a 2-mark question. So, this question can come for a 2-mark question. What will be the step to write?
Given to
Jayati, how will you write the steps? Given, prove that. Okay, after that, proof I need here.
In triangle,
Who is the Jayati? Okay, tell.
in triangle OPQ, OP square plus
It's
PQ.
wrong. You will get only maximum 1 mark, not even maybe.
Okay.
Yes.
In triangle PQO, by Pythagoras theorem.
He said in Marathi or such a Rajasthani language. Good word.
IIT.
In right angle
In Rao.
triangle.
Over.
In triangle OPQ, OP is perpendicular to.
First step you have to write PQ is the tangent at P and O. Oh madam, listen. What do you mean making? In the figure, in the triangle, this is your first statement. In the figure, this one, PQ is the tangent at P and OP is the radius. Reason you write given. Below write OP perpendicular to PQ. Reason theorem. What is the theorem? Tangent perpendicular to the radius. That is your first statement. Here there is no 90 is given. So you cannot apply Pythagoras theorem directly. Understood or not? MCQ, yes, you don't need to prove it because it is already, you know that theorem applied. Then apply your Pythagoras theorem over the set. Understood? Understood? Shetty. So that condition, it is not given nowhere. This you remember in all the questions. First and foremost thing, it's not given any question, it is 90 degree. To apply Pythagoras, first you have to prove it is a 90 degree. Write the statement. What is the statement? PQ is the tangent at which point? P. And OP is the radius, therefore OP perpendicular to P. Hope you followed. MCQ, you don't need to write the steps. Okay. Continue reading the next one. Yeah. Who? Next. Yes, read.
Draw a circle and 2 lines parallel to a given line such that one is a tangent and the other is a secant.
Draw a figure. Draw figure. Second. What is second? Draw in your the notebook. Look, not in the last page. Nobody check the last page. Main page you draw. Don't worry, I will check. Don't look in the others book. Parallel or read question here. Read. Yeah. Second is going. Done. These are how many circles?
No, sir, I was saying circle, perfect circle.
Done. Over. Scale and pencil is not there, no? Yeah, over. Yeah, we'll complete it all of you. Mister, what is this? Radius, why did you know? Ah, yeah, listen here. All of you listen. Nobody will get the mark. Nobody will. Okay, listen. Okay, man. Oh, now, yeah. Read the question. Who read the question? Yeah. Read the question.
Draw a circle and two lines parallel to a given line such that one is a tangent and the other is a secant.
So in this question, what is given? Yeah, what is given? Tangent is given.
Nothing is given.
There is a circle and a line is given. How many lines are in there in your figure? Two lines. It is not two lines. There should be three lines. Now we'll draw one more. Finish work is over now. So teacher will come in the exam hall. Hey, draw one more. So look here. Stop drawing. That is the way analyzing. That's why I asked you people to see. You have given a circle. You have a circle and a line. That line can be anywhere. Suppose the line is over here. Is it given inside out?
No.
A circle and a line. Now, what is the question? You need to draw two lines parallel to this line L, out of which one is a tangent and other is a secant. So then you will draw. Okay, tangent means either this side or this side you can draw. Let's say if I draw over here. This is the tangent and the other one is the secant. So, okay, if I take it as okay, RS. So, given condition is, if your right answer means, given condition is circle, given the circular center row and PRS is the line. It can be, this line can be anywhere, it's no need to inside external or something. Then, these are next condition is PQ and AB are drawn parallel to which one? To RS, where PQ is parallel to, PQ is the tangent at P and AB is the secant. Clear now?
Yes, sir.
One more question. I'll have construction. How to construct it? Constructions are not there. Over. Pallav. Over. More are there?
No, one more is there.
One more. Read.
A point P is located on a circle of radius 10 centimeter.
You will get. Keep the book over here and read now.
He's very
Forget now.
How many?
Now what happened? No, he is not doing anything.
Tangents can be drawn to the circle at point P.
Give the answer, Pallav.
Sir, reading.
Let him tell now.
Infinite.
Infinite. Very nice. How many of you read? A point P is located on a circle of radius 10 centimeter. Where is the point P? On the circle. Okay. And radius 10 centimeter. Radius 10 centimeter is not required anything over here. How many tangents can be drawn to the circle through the point B? How many? One. Why one? Because the point is on the circle. Are you followed? Read and identify. These are the questions come for 1 mark questions. So you have to be very careful. Understood? Yeah. Next, the number of tangents from the point on the circle. Say, read.
Number of tangents from a point on circle. Case 1. There is no tangent to a circle passing through a point line inside the circle.
Are you followed, all of you? If a point inside the circle, there is number of tangent is 0. Nothing. Second.
Case 2. There is one and only one tangent or to a circle passing through a point line on the circle.
So if a point is on the circle, how many tangents are there? One tangent. Next.
There are exactly two tangents to a circle passing through a point line outside of it.
From an outside the circle, how many tangents can be drawn? And not that the most, two. Not that the most. Always from an exterior point, how many tangents are there? Two. That means from, suppose if this is a point over here, from here how many tangents can be drawn? Two tangents. One will be this side and other is this. Okay, these are the two tangents are coming. Okay, when a point is inside the circle, no tangent. When a point is on the circle, how many tangents? One tangent. From a point exterior to the circle, two tangents. Okay, listen. All of you can close the volume and listen. Now we are going to talk about the next theorem and its properties. Okay. Now first is length of the tangent from an external point. Yeah. Length of the tangent from an external point. So from an external point, what does the length of the tangent mean? If P is an external point over here, what is the meaning of the length of the tangent means? From P, you draw a tangent to the circle. Where it is meeting, suppose it is T, then this PT is called the length of the tangent. From the external point from where? P. I repeat, what is the meaning of the length of the tangent? It is the length of the line segment from where? From the external point to which point? Point of contact. Okay, if it is coming as over here, Q is the point. What is the length of the tangent from Q to QT? Yes or no? Suppose if R is the point, RT is the length of the tangent. Suppose if it is coming as S is here, nothing is the length of the tangent. It is not nothing. How do you get the length of the tangent? From S, you draw a tangent. Where it is meeting, that length of the tangent. Are you followed? Okay, over here. Suppose if it is coming on this way. Suppose it's meeting over here. So SA is the length of the tangent. All of you followed? What's the meaning of the length of the tangent? Sure. Now, is it PR is the length of the tangent?
No.
Is it so? No. PR is not the length of the tangent. PT is the length of the tangent from P and RT is the length of the tangent from R. Clear? PR together is not the length of the tangent. Hope all of you followed. Now the theorem, that is the second theorem. Tangents drawn from the external point are equal in length. Tangents drawn from the external point are equal in length. Means from an external point, how many tangents can be drawn? Two. Both of them are equal in length. Means from, let's say for example, over here. From the external point P, we can draw two tangents now. Okay, so from here, one over here. Okay. What is the property says? Tangent drawn from the external point are equal in length. So that means PT is equal to PQ. That is your second theorem. Okay. What is the first theorem?
Radius is perpendicular to the
Tangent through the point of contact. Okay. This what is the second theorem?
Tangent drawn
From the external point are equal in length. What the theorem says? Tell. External point are equal in length. Okay, what is given? Riti. Circle with center O is given. What else? What is circle? PT and PQ are the tangents drawn from the external point to P. Naisha, what do you need to prove? That what is that? PT is equal to PQ. Are you followed? So given condition is circle with center O, PT and PQ are the tangent drawn from the external point to P. So we need to prove PT is equal to PQ. Who can prove? It's a very simple proof. Proof is important also. You're not in the school. Can you have a full mark? No? It did. Okay. Next exam you will get full mark. What your brother is doing? Give one tight slap to him. Na?
Sir, I am
Taking out your pen. Do you know what is the cost of that pen? So repairing work you will not get. Nobody will come for repair. So then listen now. It's a simple one. You can join. Okay. Complain. Tell. Nobody is referred. So you can
join OT and OQ.
Who is that?
Join
Somebody is. Share is the hand. Okay. So ladies first. Okay.
Why?
Why?
That like first theorem.
So first is the construction. Construction is join OT, OP, OQ. Okay, says.
The OT will be perpendicular.
So don't tell first theorem, tell the steps properly. Okay, so you tell. Huh?
Sir, OT will be perpendicular to, sorry.
Look here, simply don't tell OT is Look here, you have to tell this way, simply don't tell perpendicular. For that one, why it is perpendicular, first you have to write. Not simply the theorem, right? Why you have to tell PQ is the tangent at the Q and OQ is the radius. Therefore, OQ is perpendicular to PQ. Reason, tangent perpendicular to the radius. Same way, then you can write similarly, this one, OT is perpendicular to PT. That steps has to write. Okay, so then we will prove therefore these two angles 90 degree. Okay, Adish, can you prove these two triangles congruent?
Yes, sir.
Prove.
So first we can prove that PTO and O and PQO.
That is proved already.
Yes, sir.
Okay.
Then the radius of the circle, sir.
O then
Q and OT.
OT is equal to OQ because radii.
And
OP is common. Therefore, triangle PQO is congruent to triangle PTO by RHS test. All of you are following. Therefore, by CBSE, you will get PT is equal to PQ. Proof is followed. Easy proof, important proof. It can come in the exams again. Okay, should I explain? Everyone. All of you followed. Should I explain again? Anyone need the proof? No. Okay. Naisha, followed. Okay, stand up. Stand straight. Here some problem is there. Father said full time pass only at home. I was telling you now the same thing over here also. I forgot to tell she used to jump into class. That is what people now. I forgot that the way she jumping into right. Now she's getting ready to jump. Okay, what is given?
There's a circle with center O and OT.
PQ and PT are the tangents from the external point B. What to prove? That doesn't know.
OPT is equal.
OPT.
No, PT is equal to PQ.
PT is equal to PQ.
Yes.
Okay. Any construction is there?
Yes.
What is it?
Join.
Faster. Little more speed.
Join PO.
Then over.
No.
Join OP, OQ, OT.
Yeah.
Okay, prove.
So.
Doesn't know that's it, huh? Kriti. Tell.
There's a tangent PQ.
PQ is the tangent at which point? Q.
This point Q.
And OQ is the radius. Therefore, perpendicular tell now.
Therefore,
OQ perpendicular to PQ, reason is tangent perpendicular to the radius. Let me also try. Okay, then similarly, OT is perpendicular to PT. Sit down. Shetty, continue.
We are going to prove that OBT and OQ are like congruent.
O R. Triangle OPT.
So OT is equals to OQ.
First tell 90 degree. Angle OPT is equal to angle OTP is equal to angle OQ. 90 degree each. Okay, then.
Then OP is common.
Okay.
Then OT is equals to OQ. Radii.
Therefore, these two triangles are congruent by RHS test. Therefore, PT is equal to PQ. Sit down. I know, you knew. Okay. So, this property theorem followed or not from the external point? Sure. Okay. Now, suppose if I extend this one. These are extensions, okay? If I draw a third tangent. Okay. You know what is drawn over here? This is called which circle?
Cyclic.
This is called in circle. Circle inside the triangle. Circle inscribed in a triangle. What do you mean by circumcircle? Circle will pass through all the vertices. That is called the circumcircle. This circle is called the incircle. Yes or no? Yes. Now, can you prove PA is equal to BB? PA is equal to BB. This is straight line, okay, PA and BB. Are they? Viraj, what happened? You cannot prove PA equal to BB, okay? Because the PA and BB are not tangent. What are the equal things? Tell. Fast. Tejas, which are the equal things in this figure? Huh? Then AT is equal to AR. Then PR is equal to PQ. From the external point A, which are the equal conditions are coming? AT is equal to AR. From the external point B, what is the condition? PR is equal to PQ. Okay, so you have to consider the conditions. Okay. Now, open your notebook. Yeah, right. This theorem I am not making to write, okay? Write down. If when two tangents are drawn from the external point, when two tangents are drawn from an external point to the circle, when two tangents are drawn from the external point to the circle, then when two tangents are drawn from the external, keep the notebook properly and write. No, I'll give the space. Come, stand up. Your father was shouting at me. Why don't you slap him? Okay. Look here. From the external point to the circle. Then one. Then first condition. There are three conditions. One, they are equal in length. They are equal in length. Equal in length. Second, they subtend equal angles at the center. They subtend equal angles at the center. Angles at the center. Third, they are equally inclined. They are equally inclined to the line joining the center and the external point. Line joining the center and the external point. Shetty, are you writing three things together or one separately?
No.
Paragraph writing, no?
No.
Three. Okay, they are equally inclined to the line joining center and the external point. Okay, listen all of you. Stop writing or doing. Complete all of you. Okay. Kaustubh, stand up. So, in this question, what is given?
Question.
This statement, what is given? This can come up.
When two tangents are drawn from an external point to the center, then equal.
To the center.
Sorry, to the circle, then they
What
are
is
equal.
given in the question? Look at the
They are
figure.
equal in length. PT is equal to PT.
Array, my dear, what is given and what to prove? That is, I'll cut your mark. 30 or 30 and make it 20.
Who is this OT? Sir, can you repeat the question?
Question is, this is the question is given. What is given in this question? Look at the figure and hello. What is written is called the question. So what is given when your figure is given? What did you write? Given. What did you write?
There is a circle with center O. OT and OQ are radius. P.
Visha. All of you read the statement, then identify what. This is a question. Below I will write prove. Then what are you going to given and what to? Then you have to draw the figure and then you have to prove it. So the figure I have drawn for you. So what is given?
CP and PQ are equal.
That is given. That is given. That is given. What is given? That means what people are reading, but English passed out. Sit down. So the statement is written. What is? If two tangents are drawn from the external point to the circle, so that means PT, a given condition is PT and PQ are two tangents drawn from the external point P to the circle with center O. That is the thing is given. Are you followed? What is given? PT and PQ are two tangents drawn from the external point to the circle with center O. Now what to prove? There are three cases. Okay, Chaiti, what is the first thing you have to prove?
Yeah, equal in the
Means what you have to prove?
PT
PT is equal to PQ. Are you following? That's why analyze the question and tell what is given and prove. If you can't understand the question, how will you get the answer? How will you write the solution? Most of the people problem is word problems or statement problem. I know the solution, but I don't know what is asked in the question. There is nothing to laugh. The same problem only. Second thing. Wait, no, they subtend equal angle. Who will tell? Shreyas. There is no. Okay, Shetty.
I have to prove that POT and
Angle POT is equal to angle POQ. That is second thing you have to prove. Third one.
angle TPO is equal to
Angle TPO is equal to angle QPO. Are you followed? Given condition is PT and PQ are tangent drawn from the external point of the circle. We have to prove three things. What are three things? PT is equal to PQ, angle POT is equal to angle POQ, and angle TPO is equal to angle TQO. If the question comes means you have to do the proof of the congruence only. First you will prove these two triangles are congruent. Then first CPCT, PT equal to PQ. That's your first answer. Second CPCT, angle POT is equal to angle POQ. Okay, that's second answer. Third, angle TPO is equal to angle TPO is equal to angle QPO. Third CPCT. Are you followed? Try to understand the meaning of the question, right? If this question comes, all three parts may not come. Two parts can come. When the question comes, please write. Understood, all of you? Given to prove. Once if you got given to prove means then proof is very simple. What do you have to prove? These two triangles congruent. Hence answer. Hope you have followed. No problem. Theory part of this chapter is over. Chapter is over means theory part only over. This contains lot of questions are there. You have to be little more faster because I have to around 25 questions or something in that second exercise. 24 questions are there. It takes time to do it one by one. Some of the questions are repeated ones, so I will not do because similar ones I will not do. Okay. Well, third one, you only said the third one and each is asking about.
I said the second one.
A third one is they equally inclined to the line joining center and the point. That means angle made is equal. Equal inclined means what? Angle TPO is equal to angle QPO. Okay. Oh, you said the second one. Okay. Followed. Now let's start the exercise. Second exercise. 3.2. Second exercise. Read Arnav. Read the first question. First.
Point Q, the length of the tangent of the circle is 25 cm and the distance of Q from the center is 25 cm. Find the radius.
All All of you draw the figure and this again MCQ.
Questions?
Oh. Done. From a point Q, the length of the tangent to the circle is 24 centimeter and the distance Q from the center is 25 centimeter. Figure is required. That's only the figure needed. Where? Where is Q? Only Q is given and center is given. Somewhere it is given. Where is Q? Most of the cases most of you people drawn this much. Where is Q? From the point Q. This is the one. Huh? No, from the point Q, length of the tangent is given as how much?
24.
That is, this is 24. Okay. Right. Figure where? You drawn this side. Okay. What difference is it? Okay. Then center. Distance is given as 25 centimeter. Oh. Okay. Let's say P. We have to find out the radius. Okay. This one you're doing it's easy now. Pythagoras theorem. Steps you know how to write. Answer is 7 centimeter. All of you got it? Everyone, no problem? Okay. No problem. Okay. Next, the second question. Twisha.
Integral CC and PQ are the two tangents of a circle with center O so that angle POQ equals to 1 and 0 and angle PQ is equal to
So you have to find out angle PTQ now.
PT.
PTQ. How do you get? Who got? Who is that? You mean what? Huh? Silencer. Who got? Who got? You will get is something different. All will get. None. Those who got. Only Kamble. Says. Shetty. What is the answer Shetty got? 70 already got.
Because angle OP.
You also got 70? Yes. You also got 70? Okay, tell. No. Because that goes tell fast.
Angle P and Q are like 90 degree because.
Very good. There is no construction required. What is TP? Tangent. OP. Radius. Therefore, what is the angle OPT? 90 degree. OQT. That also 90 degree. In a quadrilateral, sum of the angles is equal to 180. So 90 plus 90 plus 110 plus the fourth angle is 360. Therefore, it is equal to 70. Are you followed or not? Okay. Recent steps if you want, write down. Because I don't need to give in detail. First is angle P is equal to 90 degree. Angle Q is equal to 90 degree. Tangent perpendicular radius. Then angle sum property apply. Got it or not? Everyone. Yes or no? Not followed. Achha, Mota have got some other way. Nahi. You did not get. What did you do? You joined OT. No need to join and all. You can get, but not required. Directly you get. Arjun, listen. One question over here. Listen. One question. Is it this quadrilateral cyclic?
No.
No. It is a cyclic quadrilateral. Now listen here. Is it cyclic quadrilateral means? By looking it is not cyclic quadrilateral, but it is a cyclic quadrilateral. What is angle P? 90. What is angle Q? What is angle P plus angle Q? 180. So opposite angles are supplementary means the quadrilateral is cyclic. Be careful. You can draw another circle passing through this one. So careful about these all properties. Understood? What are the I'll just sit over there. Okay. Okay. Emergency means you go this way. Okay. So this one. So let's Completed all of you, followed the condition. So next class we will discuss the continuation. Volume and the thing. Who's it, this one? This one.
पीछे